Welcome back to Physics. Today we're going to be covering the IV characteristic graphs for a filament bulb, a diode and a resistor at a constant temperature. Before we get started looking at the IV graphs or graphs of current against potential difference, we need to know a few basic definitions. Potential difference is needed to allow current to flow through a circuit, and resistance is the extent to which an electrical component restricts the flow of current. Here is our first electrical component, the resistor. We are going to look at its IV graph assuming that it's at a constant temperature. Here we have the IV characteristic for a resistor at a constant temperature. An IV characteristic is just a fancy way of saying a graph of current against potential difference. For our resistor at a constant temperature, we can see the graph has a nice straight line shape. What that tells us is that current is directly proportional to potential difference. In other words, if we doubled the potential difference, the current would also double. For an electrical component, such as the resistor at a constant temperature, if it has a directly proportional relationship between potential difference and current, giving us this lovely straight line, we say that this electrical component follows Ohm's law. For our second IV characteristic, we're going to be looking at the electrical component of the filament lamp, which is a common type of light bulb. Remember, IV characteristic is just a fancy word for a graph of current against potential difference. Here we can see that for the filament lamp, current does increase as potential difference increases. However, this is not a directly proportional relationship as the graph begins to curve. The reason for this curve is that the filament inside the filament lamp, which gives it its name, heats up as the lamp is on. You might notice this if you have a bedside lamp and you put your hand close to it when it's been on for a while, it gets really hot. Obviously, I do not advise that you touch hot lamps. As the filament heats up, it becomes harder and harder for the electrons to travel along the filament, and thus the resistance increases as it is restricting the flow of current. And for our final electrical component, we're going to be taking a look at the IV characteristic for a diode. A semiconductor diode only allows current to flow one way around a circuit, which is why we only have a positive part of the graph here. A diode's resistance is very high at low values of potential difference, which is why we have this flat line section of the graph. At a particular value of potential difference, dependent on the material that the semiconductor is made out of, resistance of the diode dramatically drops, allowing current to flow. And that's why we have this hockey stick shaped section of the IV characteristic of a diode. There you have it. We've looked at the IV characteristics for a resistor at a constant temperature, for the filament lamp, and for a diode. Here I have combined all three graphs in one, so you can see that the blue line shows the straight line graph for the IV characteristic of the resistor at a constant temperature. That straight line there representing a directly proportional relationship, which means that the resistor follows Ohm's law. Here we have the curved IV characteristic of the filament lamp, remembering that it curves as the filament heats up, the amount of electrical resistance increases, which means the current can only increase at a slower rate. And finally, we have the graph for the IV characteristic of our diode, and we see that at low values of potential difference there's no current flowing, and then suddenly at a particular value of potential difference that's dependent on the material the diode is made out of, there's a dramatic decrease in resistance which causes this rapid increase in the flow of current. Thank you very much for watching this fierce physics video about the IV characteristics. I really hope you found it helpful. If you did, please hit the thumbs up button below and remember to subscribe to the Fierce Physics YouTube channel. Click the bell so that you get notified with my latest videos so that I can help you as much as possible, and share this video with your friends if they would also find it useful. Until next time, bye!